Hi, Assalamualaikum. So, our application of linear algebra is traffic flow analysis using Gauss-Jordan elimination method in traffic flow analysis. At first, this is our group members. History of Gauss-Jordan elimination method. The method of elimination can be traced back to ancient China, appearing in the mathematical text the ninth chapter on the mathematical art, written during Han Dynasty. In Europe, the method first appeared in the notes of Isaac Newton. Carl Gauss in 1809 devised an algorithm to solve least square problems, notably using it for astronomical purposes. Gauss considered the method commonly known at the time Harvard University. Wilhelm Jordan in 1888 described a refined version of the method in his book Hamburg der Vermessungskunde. The name Gauss-Jordan elimination combined both men, Gauss, who championed row reduction, and Jordan, who popularized it, used for computing metric inverse and achieving reduced row echelon form (RREF).
Next, we move to introduction of case study. The diagram in figure 1 below describes the 4 one-way streets in Kumasi under study in the model. The data was obtained by counting the numbers of vehicles that travel around the 4 one-way streets between the hours of 6 am to 10 pm and 2 pm to 6 pm during the midweek peak traffic hours. The arrows in the diagram indicate the direction of flow of traffic in and out of the network that is measured in terms of number of vehicles per hour, VPH. The variables x, y, z, and w represents the flow of the traffic between the 4 intersections in the network. Our purpose of study are to minimize traffic congestion in Kumasi Central Business District and surrounding arterial roads. Next, to calculate the exact number of vehicles that should be permitted to traverse the 4 one-way streets, ensure continuous traffic flow. The third one is to solve the problem statement using the Gauss-Jordan elimination method. Lastly, to form linear equations and represent the system linear equation as an augmented matrix.
Now, I will walk you through the methodology used in this study to model and solve the traffic flow problem. The study involves a network of 4 one-way streets in Kumasi, Ghana, with 4 intersections labeled as A, B, C, and D. The traffic flow between these intersections is represented by 4 variables, X, Y, Z, and W, each measuring the number of vehicles per hour along a specific road segment. To formulate the mathematical model, we apply one key assumption. The number of vehicles entering each intersection must equal the number of vehicles leaving it. This is known as the conservation of flow principle. Applying this principle at each of the 4 intersections, we obtain the following system of linear equation. At intersection A, x plus y equals 431. At intersection B, x plus w equals 255. At intersection C, z plus w equals 340. At intersection D, y plus z equals 516. With the system established, we can arrange this equation into an augmented matrix, placing the coefficient and constants in a structured format. Next, we need to express the system in an augmented matrix form. And then we need to solve using the Gauss-Jordan elimination method. And step 5, we need to obtain the general solution. And step 6, we need to substitute the W value. So for the solution, we need to apply the Gauss-Jordan elimination method, which is a systematic process of performing elementary row operation to transform the matrix into its RREF form. So first, from the augmented matrix form that we have formed before, first we need to take row 2 and minus it with row 1. And then step 2, we need to change the fourth row and add it with row 2, the value in row 2. And then step 3, we need to take the fourth row and minus row 3. And step 4, we take the second row and we multiply it by the negative value of the row. And finally, step 5, we take the first row and minus it with the second row. After the 5-row operations, subtracting rows, adding rows, and multiplying by -1, we arrive at the final RREF. The last row becomes all 0, which tells us that the system has infinitely many solutions. So from the RREF, we express each leading variable in terms of W, which is our free variable. X equals 255 minus W, Y equals 176 plus W, and Z equals 340 minus W. This general solution means that the traffic flow can be adjusted along different road segments depending on real-world conditions, as long as the values of X, Y, and Z remain non-negative. So now we're moving on to the results and discussion. So in this study, a construction restriction was imposed on the Labor Asafo Interchange Road, limiting its traffic volume to 100 vehicles per hour. So we set W equal to 100 and substitute this into our general solution. This gives us the following optimal traffic flow values, which are X equals to 155 vehicles per hour on Atonsu Prempe Road, Y equals 276 vehicles per hour along Roman Hill Road, Z equals 240 vehicles per hour on Asafo Market Kajetia Road, and W equals to 100 vehicles per hour along the Labor Asafo Interchange Road. So from these results, we can observe that the Roman Hill Road carries the highest traffic volume at 276 vehicles per hour, making it the primary arterial road in the network. Authorities should prioritize this road for maintenance and capacity management. The fact that the system produces infinitely many solutions also has a practical meaning. It shows that the traffic engineers have flexibility in managing flow. So by using the traffic lights at each intersection, the authority can effectively control the value of W and in turn regulate the traffic across the entire network. So, in conclusion, the study demonstrates that linear algebra, specifically the system of linear equations solved using Gauss-Jordan elimination, provides a powerful, systematic, and data-driven approach to solving real-life work traffic congestion problems. The methodology is replicable and can be scaled to model more complex road networks in the future.
In conclusion, this case study successfully solved the vehicular congestion in Kumasi. By treating a network of 4 one-way streets like a map problem, we use system of linear equation, which is Gauss-Jordan elimination, to model and analyze traffic flow within a network of 4 specific one-way streets in Kumasi, Ghana. Gauss-Jordan elimination offers a structured approach to analyze and resolve such problems by reducing them to their simplest form. If the city follows these specific vehicle targets and improves the road's infrastructure, they can significantly reduce the time people waste sitting in traffic. This study also shows that mathematical concepts learned in linear algebra can be applied to real-life situations and can help solve practical problems effectively.